Welcome back, gangies. We're back once again to do some more hyperbolic coding in the chambering of coding. So here we are. I don't think we have any comments today, unfortunately, so we won't be able to stall inevitably. So I think we don't have any comments, so we have nothing to do but accept our fate and return back to the grind. So feels bad, man. Feels bad indeed. But I think things are going well. I was rewatching, I think, a video from yesterday or the day before, and I was so tired in that video, which is pretty crazy. I'm less tired today, but I'm already kind of pooped. So, gonna do a classic 30-minute session. I'm actually not certain how long we'll be doing 30 minutes. I thought we might come back to an hour soon, but we'll see. I could see us getting back to an hour. I think part of the issue is I've been learning a lot of AWS stuff on the side, and this takes around 30 minutes, and it kind of takes some of the brain juice that I used to have remaining for doing longer LeetCode sessions and puts them into some AWS stuff. So that does kill some of the brain sauce. So give and take, right? LeetCode is important, but also we need some other skills as well. Also, AWS is, pretty archaic. With how fast things are evolving, I really wonder in the future if computer science or programming will be like becoming a doctor or something like that. Like it'll take not as long, because becoming a doctor takes long. What I'm trying to get at is that becoming a doctor takes so long in school. I'm wondering if, as hard as computer science is becoming with all the stuff they're adding, I really wonder how long it'll take for like new people to get into it. Because imagine this, if when you start with HTML, it's just HTML, JavaScript, and CSS. That's subtracting all the stuff you need to know about how the browser works, networking, requests, and all that stuff. Then you get something like Rails, right? You're like, okay, server, services, stuff like that. And then you're like, okay, well, people aren't using JS anymore. So, people aren't just using JS by itself. They're using TypeScript and stuff like that. So then you need some kind of Webpack bundler thing to transport all your JavaScript and whatnot into a shippable intermediary that compiles it into all the stuff so it works on 40 different browsers. And then from there it's like, okay, we're using React. Well, now you can also do ISG and SSR and SSG and islands. And then now there's Next.js, which is like a thing on top of another thing. And then I'm not saying that none of this makes any sense, but none of this makes any sense. There's just a lot going on. And obviously, I think it does make sense when you take a really close look at it. But I can't help but look at it from a new person point of view, and I'm still new. And I feel like this is crazy. You learn stuff in school about programming, and then you're like, well, okay, now to also get a job, you have to do X amount of LeetCode problems. You also need to show up to the interview being able to ship a feature, do infrastructure. But then you just got out of school, so you also have to learn Docker and AWS and ECS, and you have to deploy, and you also need to understand how to do Terraform and Terraform Apply. There's a lot in there. And then layered over all of that, there's a layer of skill where it's like, okay, you can't just make a service. You have to design a service. What's a good service? What's a bad service? What's this pattern? What's that pattern? There's good code. There's bad code. There's good comments. There's bad comments. Software is actually crazy. So I'm wondering if in the future colleges will just have some accelerated pipeline where it's like a trade school where it's just literally we're going to throw you through the ringer and not like make you learn a whole bunch of stuff you don't need to know, because the discrete math and stuff, it's not coming through right now. So this is just to say, and every year more and more complexity is being added. So it's just crazy. I think the people at the top aren't having much trouble keeping up because they're just using natural evolutions of their tools. But now it's already faster than that. If you were using something like, I don't know, Next.js, there's already, 2 or 3 other options you can use now. And Next.js is already kind of considered cutting edge. So it's just crazy. It is just crazy. But yeah, and then on top of all that, you got to learn like all the AWS stuff or, whatever cloud provider one is using. It is actually crazy. I feel like it's a lot more daunting than is initially let on. So, yeah, it's just tough. So I really wonder how starting from scratch would be bonkers. So shout out to the people who are doing that. And maybe they're just following a specifically curated path so as to not end up like having to do a bunch of other stuff. Like we had to do discrete math and like graph theory and all this stuff. And then actual work is like, okay, we're deploying a feature. How do we deploy it? What does the good code look like? What's the change look like? You have to communicate it to the stakeholders. Where's the discrete math here? Where's the graph theory? So it's hard to know. Maybe schooling is part of like exposure therapy. You just need to get exposed to it to know something's possible. But if that's the case, who knows? We're just rambling. All I'm just trying to say is I've been learning AWS stuff. There's so many they have like 80 services. It's crazy. And I was thinking about a new person, or I guess someone newer than me starting. And it seems like it would just be a lot. So, yeah. So, yeah, that's where we're at. We're going to jump into the LeetCode. I just talk about nonsensical madman stuff sometimes. So, that was just me. Nothing. I don't really have anything concrete to say about it. I just wonder how difficult it must be for people newer than me, because it's already hard for me. So, but that's where we're at. We're going to do 30 minutes. We're trying to do largest triangle area, and I think we have some good intuitions about how to make it work. Unfortunately, I think the formula we're using to calculate the area of the triangle only works for right triangles. So you need to use a formula based on 3 points to do it instead. We actually don't even need a function for this. We'll change this to max area. Here, and we'll return max area. Then up there on line 8, right, we can actually create area, and this is where we use our function for finding an area of a triangle based on 3 points. Unfortunately, I don't know this off the top of my head, and I hope I would never be asked this in an interview, but hopefully we can figure out what it's called. Okay. We can calculate an area of a triangle using this really convoluted formula, which I have on my phone, that I'm going to try and relay to here. So we have 1/2. So it's going to be 1/2. 1/2. So 0.5 times the math.absolute value, and we're going to have a bunch of stuff in here. The first thing we're going to have is x1 parentheses, so x1 times y2 minus y3 plus, right, x2 times y3 minus y1 plus x3 times y1 minus y2. So we can just say constant. X1 is going to be equal to say x1 y1 is equal to points sub anchor. X2 y2 will be points sub I. X3 y3 will be points sub j. So let's see if this makes any sense at all. Okay, it works for the first one. Nice. So it turns out we're not completely delusional. So that's always exciting to see. So it doesn't get much better than that. So I think I'm cool with that. So how long would this take? We're going over the points. I mean, I'm pretty sure this is just going to take cubed time. And I wonder if it even matters about this if statement I put here. Okay, it doesn't matter. We could have used any. It's pretty much just cubed time in the end. So I'd say p cubed. Now we have sum of root to leaf binary trees. You are given the root of a binary tree. You're given the root of a binary tree where each node, binary tree, each node has 2 children. Each node has a value of 0 or 1. Each root to leaf path represents a binary number starting with the most significant bit. Interesting. For example, if the path is root to leaf starting with the most significant bit, right, this is 13 because we have 8 and 4 here, and then 1. And this could be represented as 0, 1, 1, 0, 1 in binary, which is 13. For all leaves in the tree, consider the numbers represented by the path. For all leaves in the tree, consider the numbers represented by the path from the root to that leaf. Return the sum of these numbers. The test cases are generated so that the answer fits in a 32-bit integer. So we have 100 plus 101 plus 110 plus 111. It's useful that it is already created in the most significant form, because that means we can just add them all to a number, or we can shift it onto, it's pretty much shifted onto itself, which doesn't make much sense when explaining it. But if we can shift the bits starting with 1 or 0 from the right, from the least significant bit to the left, because it's already reversed for us. I think we could do this recursively, right? Once we go down, we want to return a number, and if you, actually maybe we can't. We want to keep track of our path, so we need some recursive function which keeps track of that path, or a parameter. So we could do that. And so we pretty much want to add our current, we keep track of our path. We have 1, 0, we have children, and as soon as we don't have children, we want to convert our number into a value and return it. So I think we could do that, and we could make a function called traverse, right, which would take a node starting from the root, a current path, which, you know, actually could just be a number which will start at 0. And I think that might be all we need. This function traverse would take a node, which would be a tree node or null, and a number, which is n, and it would also return a number. Fortunately, since all these are going to be by value, right, where we are in the stack or where we are in the tree, right, will be preserved and shifted and popped off onto the end of n, and we'll be able to retain basically what in each node in the binary tree we'll be able to retain state related to where we are in our number. So let's just say if node exists, right, actually we could do it like this. If the node exists, continue. If the node doesn't exist, that's when we know our previous node was a leaf, so we can just return that value. So that's actually pretty cool. So if the node do some work, right, else, right, we can return n. So if the node exists, right, what do we want to do? We want to keep traversing deeper, but first we want to say we're going to check the value of n, right? We're going to say n is equal to n, or, right, bitwise, or if n, or not n, if node dot val and 1, which means the number is 1, right, then we want to add 1. Otherwise, we want to add 0. So we'll basically shift n's bit to the left once, right, and then add a new number on. And then we can do traverse node dot left. I see we actually get too many numbers, so in fact let's just say if node the case where the else will be we're a little stumped. The time where we would do the work would be when the node doesn't have any children. So if node dot left, if not node dot left, we want to do this work, right? We're in the node, we want to do this work. The question, right, of if we continue going or if we return what we have is going to be done here. If the node dot left if the node doesn't exist, return 0. Now, if we're in a node, it doesn't have left or right, Alright, this light is blinding me. And we're going to traverse node dot right. We're not going to return them though. We're going to say output plus equal. So we have 1 0 0. We start with 1, right? A node exists, so we push on. We bit shift n to the left once. We add 1 to the number, and then we traverse. So left does exist. So we do output plus equal traverse node dot left. So then we go to 0. The node does exist. We add a 0. And then we go to node dot left again. We add a 0. Node does exist. Oh, well, the node doesn't exist. Wait. Does a leaf have no children? Oh my god, a leaf is a node with no children. We'll return n. So we start with 0, with 1, modify the number, both exist, so we go left, right? We do the traverse of both. We're in 0, we do the traverse of both. Now we're in 0, right? And it has no left or right children, so we just return n, right? And now we want to check the right hand side, go into it. It doesn't have any children, we return n. I think this should work. Yeah, this one had me stumped for a second. I almost thought we were in trouble. Or we figured out a way to make the traversal work in the end. So I think this would take linear time. So we're still avoiding another problem. Let's try to find the k-beauty and odd string difference. Find the k-beauty of a number. The k-beauty of a number, the k-beauty of an integer num. the k beauty of an integer num is defined as the number of substrings of num when it is read as a string that meet the following conditions. It has a length of k. It is a divisor of num. Given integers num and k, return the k beauty of num. K beauty of an integer num is defined as a number of substrings. The number of substrings of num when it is read as a string has a length of k and it is a divisor of num. So it must have a length of 2 and must be a divisor of num. So 24 does divide 240 and it is k length long. Does 40 divide 240? It does. Looks like you can just sliding window across this of size k. And just check the math, right? That it's at least k length and it divides the number perfectly. So let's try sliding window across string plus math. Do sliding window, we'll say constant. Do we need the number as a string? That would be helpful. Actually, we'll just make this stir. And then we'll say, well, if stir.length equals k, then we'll do work, right? Otherwise, we're just going to say, we're just going to add the characters to the window, right? So we have to build the window before we can start sliding it. We'll say stir plus equal num as stir sub I. And then we'll keep a count. So first, the order matters, right? We do the work, then we add the character, right? We can also check again if stir.length is greater than or equal to k, right? Then we can say stir is equal to stir dot splice 1 or substring 1 to remove the first occurrence. So if we think with 240, right, we'll start at 2. 0 does not equal k, so we're going to add 2 into the string, right? We're not greater than or equal to k, go to the next one, right? 1 does not equal k, so we're going to add 4, right? And I should have said string length is greater than k, right? We go to the next one. String length does equal k. Now we do the work, then we add on 0, right? But now we're greater than it, so we remove it. The problem is we'll skip 0 at the end because we need to do 24 and 40. So maybe we should do this removal part at the beginning. So if we did it this way, right, if it's greater than k, we remove the first character. Let me see how big k can be. K is going to be at least 1, so we can at least start it with num as stir sub 0, and then we can start I at 1. Then we can say stir.length is greater than k. If it's equal to k, so we should do the work, right? Then we add the character, then we remove right, so now we have 2, 4. Now it equals 2. We do the work, then we add on 0, then we remove it, which kind of sucks. So I think we're just going to have to add one more at the end, because I don't know how to make this not. We'll just say duplicate if work. When we're 0, right, we know that the length is the same already, so we want to just take the number, right, which is just going to be string, parse int the string, and we're going to say if num already exists. We'll say if num, right, mod parse int stir equals 0, count plus equal 1. Nice. I really don't like that early. I don't like this extra if statement, but we could probably sit down and think a little bit more about how to remove that. But I think we'll stop there for today.